Good morning class 10. Now in this video we are going to learn about how to prove that a certain number is irrational. We already know what are rational and what are irrational number. Now in this video we will learn how to prove that a given number is an irrational number. Like we know certain example of irrational number are root 2, root 3, root 5. Very basic example. You must have read them many times. Okay. Now we are going to prove that these are irrational numbers. We are going to prove with a method. There is a certain method of proving this. Okay. Now before proving this, there is a theorem in your chapter. There is a concept in your chapter, and that is what that theorem says. If there is a prime number p, and if this number divides another number, this prime number divides another number, if this p divides, I am writing in short, okay, a square, if this p divides a square, then, or you can say, if I write it correctly, if the p divides a square, then p should also divide number a also, number a. Now this will understand by an example, don't worry. Now suppose the prime number I am taking is, suppose it is 2. 2 is the prime number we know very well. Now we know 2 can divide 64. So 2 can divide 64, and what is 64? 64 is 8 square. So if 2 is dividing 64, if 2 can divide 64, then 2 must also divide 8. Okay, as per this theorem, 2 divides 8 square, then this 2 must also divide 8. That is true. This is what this theorem says. Now with the help of this theorem, we are going to prove that a certain number is irrational. Okay, we'll use this theorem. Now suppose we have to prove that root 2 is an irrational number. We have to prove that root 2 is an irrational number. Okay, now how will we prove it? So we start the process. First of all, assume that root 2 is a rational number. Okay. One of these it has to be, either it should be irrational or it should be irrational. Okay. So I am assuming that root 2 is a rational number, and we know we can write the rational number. We can write the rational number in the form of a by b. Okay. So now root 2 is a by b. Okay. Now squaring both sides. So what will we get? Root 2 square is 2. That is a square by b square. A square by b square. Now taking it further, solving it further, we get 2 equal to a square by b square. So we can also write b square equals a square by 2. Now we know a and b are integers as per the definition of rational number. So b square is also an integer. So it means as per this, a square is completely divisible by 2. Only then b square can be an integer. So now if a square is divisible by 2, we know, we have just discussed the theorem. So a must also be divisible by 2. Okay. So now as a is divisible by 2, so we can write a as what? 2k. That a should be multiple of 2, only then it will be divisible by 2. So I am writing a equal to 2k. So just put this value over here. So what we get? b square equal to 2k square by 2. So this is 4k square by 2. So what is this? 2 to the 4. So now we are getting b square equals to 2k square. Now this is what we are. b square equals to 2k square. Okay. Now if b square equals 2k square, then we can say b square is completely divisible by 2. Divisible by 2. Now remember that theorem once again. If b square is divisible by 2, 2 is a prime number, then b is also completely divisible by 2. Okay. Now we got that a is also divisible by 2, b is also divisible by 2. It means a and b are not co-prime, which is a must condition in the case of rational number. So our assumption is totally wrong. We have assumed that root 2 is a rational number. So this is not true. So we can say root 2 is an irrational number. So clear? That is how you can prove for any number that that given number is an irrational number. If that is clear, the same method you have to follow again and again. So I am just summarizing. First, you will assume that given number is a rational number. Then you can write the given number as a by b, where a and b are co-prime. Then you will square both sides. Okay. So by that method you will get a and b will both have a common factor. Okay. If that number is not rational, a and b will both have a common factor. So at that time we will say that our assumption was wrong. So given number is a irrational number. Clear? Thank you.